Every day, the floor of a major hotel lobby is pounded by thousands of shoes, rolling luggage, and loaded housekeeping carts. Managing this volume of traffic is a problem architects have been trying to solve for decades. Even back in the mid-20th century, as travel surged, keeping a lobby looking elegant under the weight of constant foot traffic was a major engineering challenge. Today, the physical threats are even more severe. The floor has to absorb the concentrated friction of 50-pound roller bags, along with the scraping of heavy banquet tables and lounge chairs being dragged across the room. A premium rug designed for a private home would be structurally destroyed within weeks if placed in this environment. High-traffic commercial reality requires a complete departure from the manufacturing standards used for domestic flooring. When you check into a 5-star resort, you might expect the carpets to be as thick and plush as possible, assuming that depth is the ultimate signal of wealth and comfort. The architectural reality is the exact opposite. In a high-traffic commercial environment, thickness is a critical liability. So if deep, plush fibers guarantee failure, how do these massive lobby rugs survive millions of footsteps while still looking completely pristine? True commercial durability requires designers to look past traditional residential markers of quality and focus instead on internal structure. When a heavy wheel hits a deep pile carpet, it sinks directly into the long vertical fibers, creating immediate rolling resistance. As it moves forward, those fibers wrap around the wheel, acting like a physical brake. This friction makes dragging heavy luggage exhausting. Another issue is appearance retention. When tall fibers are repeatedly struck by heavy footsteps, they lose their structural integrity and fail to spring back. This repeated compression creates permanent, visible ruts, forming ugly, flattened walking paths in front of reception desks. In these high-traffic commercial spaces, preventing that kind of structural collapse is more important than offering initial underfoot softness. Manufacturers solve this by relying on two specific engineering choices: an extremely high tuft and knot density combined with a very low pile height. Looking at this cross-section, you can see how tightly packing short fibers together creates a dense, near-solid structure. Heavy loads sit right on top of the surface, allowing wheels to glide effortlessly. Achieving this density requires the right material. This is why natural wool is the dominant fiber used for high-traffic zones. Unlike many synthetics, wool has a natural coiled structure that gives it immense mechanical strength. It acts like a microscopic spring, allowing the carpet to bounce back into shape even after absorbing heavy impacts. You rarely see delicate fibers like silk used extensively in these main areas. Because silk lacks that mechanical resilience, its use is strictly reserved for controlled, low-traffic environments. Even a dense wool rug has a weak point: its edges. To survive constant lateral impacts from vacuum cleaners and luggage wheels, commercial rugs need heavily reinforced borders to prevent the structure from unraveling. Luxury in a hospitality setting is a direct product of this level of calculated, dense engineering. Because these rugs serve such a specific structural purpose, the industry categorizes them as contract textile flooring. Beyond surviving physical wear, these engineered textiles perform a crucial secondary function. In lobbies full of reflective marble and concrete, dense wool flooring absorbs ambient sound waves, preventing the space from echoing. This engineering logic scales across the entire property. While the main lobby requires an ultra-dense workhorse, a private suite, which sees far less traffic, allows for the deep pile variations seen here. This means a designer's single aesthetic vision has to be mathematically adapted. A pattern that works on a massive low-pile lobby rug must be entirely reproportioned to fit a smaller, softer construction upstairs. The effortless glide of a suitcase across a vibrant lobby floor is the intended outcome of invisible fiber engineering and high-density construction.